Hi everyone, this is Ants. Right here, this is 100 individually loaded GLTF files of the Dragon to mimic 100 different models. And it's using my 2 lines of code implementation of an LoD, level of detail solution. Because if you don't have a level of detailed solution, you can't compete in terms of drawing a lot of models on the screen within the camera's frustum. You won't be able to compete against basically anything because all the other ones have an LoD solution built in. Now, there's many other examples from IRCA and also Monstrous of an LoD solution, but my solution basically is 2 lines of code, but technically could be integrated into MGSX gdx-gltf, where transparently you get automatically level of detail solution. So the developer doesn't have to do any coding, but 2 lines of code today with the possibility of 0 lines of code. Right? So let's compare this 1200 FPS to stock libGDX. Right? So let's comment out this and let's just load files the regular, slow, and inefficient way. I love my comments. And let's load this. And we're at 710. So it's not twice as slow, but my solution is almost twice as fast. And believe it or not, the more models you add and the more stuff you see on the screen within the camera's frustum, the better my solution does, right? So again, it really depends on the scene, but it's generally close to double in the end. If you compare the two, I should have did a screenshot of the before and after. These far away models here, well, in this example, they're all drawn with the same amount of triangles, which is a waste because you don't need to draw at the original size triangles, these models far away. But anyways, as you can see, is what I'm proving to you is libGDX seamlessly needs an LoD solution built into it, or at least in gdx-gltf, because you could almost double the FPS, right? And the more stuff you have on the screen, the bigger gains you get, okay? So hopefully I convinced you on that. And then just for reference, Godot. So Godot, you literally don't, it's the same. You load it and you get LoD, but I tried to turn it off, so it's set to like 0 right now. And I'm getting 840 FPS. So exact same, 100 models, and Godot is generating 840 FPS compared to 720 on libGDX. So even stock Godot with very little LoD is doing well. But if I actually change the threshold, it's now cranking up to 1200. So you can notice back here when I increase the threshold, the sizes are getting like really ridiculous, and you could crank it up. But what I'm trying to get at is your engine should have LoD support built into your pipeline, right? Okay. So I just added that as context of where libGDX is with the with other open source alternatives. But anyways, so what's the secret sauce of this? The secret sauce of this is per GLTF file, my solution loads metadata in a .lod file, right? And it has to be the same name as the GLTF file. And I created it so that if it doesn't find an LoD file, like my solution basically, if something goes wrong or there's no LoD file, then it behaves exactly the same as MGSX's gdx.gltf, right? So it's transparent, right? So anyways, all this has is the breakpoints of when to switch LoDs and for every single mesh, all the different LoDs, right? That's basically the secret sauce, and all I do is swap out indices of the model. So in IRCA's solution, he has different LoDs in different LoD files. GLTF files. He literally has a separate GLTF file per LoD. That's really inefficient because you have to actually load another file, right? This one, and not only that, it's actually more complicated, right? Because now you have to keep track of all these different files. In this solution, it's just one file and you get up to 8 LoDs, right? And in terms of coding, right? It's just on load, it's one additional line of code. As you can see, new, load the LoD metadata, and it scene just loads the metadata. And then on render, it's one additional line of code, which is SceneManager.update LoDs. And the cool thing about this is if we convince MGSX to kind of incorporate this update into the existing SceneManager update, then it's transparent to the user, and we could do the same thing on LoD, on GLTF LoD or whatever. We could incorporate that. And by the way, it's still far away from that because right now this is not this LoD file here. The serialization in TVM and GWT do not work because these are my data transfer objects are an array of short, and I don't think the serialization works on an array of short. So it doesn't work under TVM and GWT today, but I have a feeling we get Tommy on this, he could figure it out. And not only that, we could reduce the size of this file, and I'll show you the size of the file in the tool. So anyways, the question everybody's asking is, okay, great, I understand what you're doing, but how do you generate this level of detail file? Well, I'm going to show you. It's with the tool that I created, right? So let's start the tool. All right. This is the tool over here, and on load of any import, it automatically optimizes. So you actually get optimization on import, but right now it's also generated on import the number of level of details in the GUI. Right now it's set to 8. By default, it's 8, and it generates. So keep an eye on this section here, and while I'm zooming out, it's swapping the indices. So the vertices remain the same. I'm just swapping out indices. And as you can see, the furthest away is a 94% reduction in indices. So you're drawing less triangles. That's the whole point of this thing, right? And so this is done on import. You don't have to do anything other than if you don't want that many level details, you just change that. The other thing, and you can use the defaults, is you set up the breakpoints of the camera distances to basically trigger the changing of LODs. Now, in a way, this should be an equation or a threshold or and all that kind of stuff. In Godot, it's thresholds. This implementation gives a lot of control, but it's probably not ideal. Again, I don't consider this a big deal. And it gives full control. And you could use this tool to actually play with the breakpoints. And if you don't notice any changing of the LOD, that means I did a good job because it's so slight in the perfect timing of the distance and the transition. Okay, so everything looks good. What do? You just click export, right? You select the directory where you want to export. You click OK. And not only the optimized GLTF file is saved, but also all the metadata of all the 8 LODs in the one single file is generated. So it's 1133. And as you can see here, it generated a file. It's 800K for 8 LODs. So that sounds like a lot, but these textures are over a meg each, right? So, but in a way, you're getting 8 models, right? So yeah, so it's a good value for this. Oh, by the way, and also the way it's encoded could be reduced probably. So here's the file. Again, it's the same file, and that's basically it. That's the workflow, right? Workflow is import your model, click export basically, and test out the breakpoints. Everything looks good, and you're good to go. So that's basically it. Yeah. Hope you enjoyed that. Take care. Bye.